Displacements in the same direction produce constructive interference.
The first example I'm going to draw for you is when two pulses meet. The larger of the two pulses will be moving towards the right or towards the inside, and the smaller of the two will be moving towards the left. These pulses are traveling on the same stretched rope and are traveling towards each other, so when they meet, their pulses will be added together, forming a resultant wave. This resultant wave looks like this.
This next example that I'm going to draw is when two pulses exactly coincide. The amplitude of the resultant wave is exactly the sum of the amplitudes of each pulse. This is also known as the superposition principle. According to this principle, when two or more waves travel through a medium at the same time, the resultant wave is the sum of the displacements of the individual wave at each point. Ideally, this principle holds true for all types of waves, both mechanical and electromagnetic. However, some experiments show that in reality, the superposition principle is valid only when individual waves have small amplitudes. The last example I'm going to draw is when two pulses pass through each other and each pulse has the same shape as it had before the wave met. This is true for sound waves at a concert, water waves in a pond, light waves, and other types of waves. Each wave maintains its own characteristic after interference, just as the two pulses do. Displacements in the opposite direction produce destructive interference. When displacements have different signs, one being positive and one being negative, the displacements are added together through the superposition principle. Because one displacement is negative and the other is positive, when they are added, they will form a resultant wave. The resultant wave can either be formed like this or like this. Both resulting from a positive and a negative displacement. And after the pulses separate, their shapes are unchanged from when we first saw them. Another type of destructive interference is known as complete destructive interference. This is when two pulses of equal amplitude but different displacements, basically they have opposite signs, coincide together. When the displacements are added, the resultant wave has a displacement of 0. In other words, the two pulses will overlap, completely canceling each other out, as if there was never a disturbance at all.